Hey folks, and we're going to continue to develop and utilize some more rules or shortcuts for computing derivatives. In this section, section 3.4, we are going to learn the product and quotient rules. As I said, in this section, we're going to add two more rules to our list of rules. And remember, these rules allow us to quickly and efficiently compute derivatives. And I should mention that, again, these rules are shown to be true by using the definition of the derivative. So our first new rule is the product rule. The product rule is used when we have two differentiable functions that are being multiplied. Hence, it's called the product rule. So here it is, folks. Here is the product rule. So it starts off by saying if f and g are differentiable functions, then the product f times g is differentiable, and it is given by, all right, the derivative with respect to x of f of x times g of x equals the derivative of f of x times g of x plus f of x times the derivative of g of x. Or in the prime notation, it's f prime x times g of x plus f of x times g prime x. Now, folks, when I first learned this product rule, I kind of knew it by, I kind of remembered it via English. That, I have two functions that are multiplied together, function f and g. And so the derivative of the product is the derivative of the first function times the second function plus the first function times the derivative of the second function. Another note is that the product rule can be extended to the product of three differentiable functions, and it would look like this. And so in English, I kind of know it as the derivative of the first function times the second function times the third function plus the first function times the derivative of the second function times the third function plus the first function times the second function times the derivative of the third function. And I don't know why I have two equal signs there. That's a typo on my part. So let's look at an example where we can practice this new rule, the product rule. So here in this example, you see the functions for part A, part B. You know to get this written in your notes because I'm going to head off to the chalkboard and do it. Hey folks, in this example, we're going to practice using the product rule. So in the first part A, we're supposed to differentiate the function f of x equals x squared times the quantity 2 square root x plus 1. The first thing I'm going to do is rewrite that square root x as x to the 1/2. All right, so now we're going to crank this through the product rule, and I'm going to kind of highlight the two functions that are being multiplied together here. The first function is x squared. The second function is 2x to the 1/2 plus 1. So when I get the derivative using the product rule, I'm gonna actually verbalize the English on how I remembered it. The derivative of the first function, so that's 2x, times the second function, plus the first function, times the derivative of the second function. So the derivative of 2x to the 1/2 plus 1 is just x to the negative 1/2. And we can multiply this together. You would add the exponents and you could distribute. Oh, let's go ahead and do it. Just for fun. Distribute the 2x so you get a 4x to the 3/2 plus a 2x plus x, add the exponents to the 3/2, and see, combine like terms. So we get 5x to the 3/2 plus 2x. Yeah, I could factor out an x, but I'm done. I wanted to focus on getting the derivative using the product rule. So in part B, let me do the same thing. Let me identify the two functions that are being multiplied together. So the first function is x cubed minus 8. The second function is x squared plus 4. So the derivative is, using the product rule, the derivative of the first function, so that's a 3x squared, times the second function, x squared plus 4, plus the first function, x cubed minus 8, times the derivative of the second function, 2x. Now, I'm not going to go any further on that one. Product rule. It's kind of a nice rule to know, and especially for what's coming up in a couple of sections. So, hey, let's head back to the slides and see what the next rule we will learn is called. All right, folks, product rule, pretty straightforward. The next rule we're going to look at is called the quotient rule, and it addresses how we differentiate two differentiable functions that are being divided. So here's the quotient rule. F and g are two differentiable functions. Then the quotient f divided by g is differentiable for g of x not equal to 0. And it's given by, well, the derivative of f of x over g of x equals f prime x times g of x minus f of x times g prime x. And then all of that is over g of x squared. And again, g of x cannot equal 0. And then, a note I have on this would be the English for when I first learned the quotient rule. I mean, when I first learned this quotient rule, I remembered it as the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator, all of that stuff over the denominator squared. So let's practice our new rule here. So in this example, let's differentiate the following. So you see the three functions, parts A, B, and C. Again, get this written in your notes because, I'm going to head off to the chalkboard and work through this one. Hey folks, let's compute some derivatives here. In part A, the function is 3x squared plus 5x plus 1 over x squared minus 1. So to get the derivative here, we're going to use the quotient rule. So I will verbalize the English on how I remember the quotient rule as I do this one. Obviously, this is the numerator. So the quotient rule says the derivative of the numerator, that's 6x plus 5, times the denominator minus the numerator times the derivative of the denominator all over the denominator squared. That's it. That's the derivative. I'm not going to do any simplifying. I'm not going to FOIL and distribute, combine like terms. That's algebra. I just wanted to practice the mechanics of the quotient rule. All right, part B, well, kind of ran out of room. So let me bring part B right here. So part B, the function is 2x cubed. All right, folks, this is an old one. I am not thinking, let's crank this through the quotient rule. I'm thinking, why don't I just rewrite the function as 2x to the negative third? Then I immediately get the derivative to be a negative 6x to the negative fourth. Or if you prefer, negative 6 over x to the fourth. So that's all there is to be. Okay, now part C. All right, we have a lot going on here. We're going to use the quotient rule. So remember, the quotient rule is going to say we need to do the derivative of the numerator. Now look at the numerator. The numerator is a product. So while using the quotient rule, while getting the derivative of the numerator, I'm going to have to use the product rule in order to get the derivative of the numerator. So let's see what this looks like. The derivative of the numerator, so that's the product rule. So with the product rule, that's my first function, that's my second function. So the product rule would say the derivative of the first function, which is 1, times the second function, plus the first function, times the derivative of the second function. So that's a 4x. So this is the derivative of the numerator. That gets multiplied by the denominator. Remember your quotient rule. The derivative of the numerator, which we just did, times the denominator. So let me put this in brackets because it's times the denominator minus, and I apologize, I'm going to have to come to a new line here, minus the numerator times the derivative of the denominator. The derivative of the denominator is 3x squared. And then all of this mess, so you know what, let me get out my red chalk here and say what I've enclosed in the red braces and using the quotient rule, that's the numerator. And so all of that is over the denominator squared. Yeah, I'm not going to simplify that. That's about the nastiest problem we could do right now. While using the quotient rule, we had a product rule embedded inside of it. I do want you to practice a couple of these right now. You won't see anything as nasty as that. So in the exercises, do numbers 26, 40, and 58. So you know the drill. Pause the video, do 26, 40, and 58, and once you're done with that, restart the video, and I'll be here at the chalkboard to work through them. All right, number 26, you were asked to differentiate h of w equals w squared minus 1 over w squared plus 1. So we have to use the quotient rule. So the derivative is the derivative of the numerator, which is 2w, times the denominator, minus the numerator, times the derivative of the denominator. Well, the derivative of the denominator is 2w, all over the denominator squared. And you know what, just for fun, just a little bit of algebraic practice, let's clean this one up, let's simplify it. So in the numerator, we could distribute the 2w here to get a 2w cubed plus a 2w. Here we could distribute, well, it'd be a negative 2w, so a minus 2w cubed plus a 2w. And that's all over a w squared plus 1 squared. And then look in the numerator, the 2w cubes cancel out, so we're left with 4w over w squared plus 1 quantity squared. So that's the derivative, and this is what we get after we do a little bit of algebraic simplifying. Number 40, you're asked to differentiate y equals w to the fourth plus 5w squared plus w over w squared. Folks, I am not thinking quotient rule on this one. I am thinking this is like an old problem. I could rewrite this as 3 separate fractions. That's what the meaning of a common denominator is. Then simplify. W to the fourth over w squared is w squared. 5w squared over w squared is 5. W over w squared, well, that's a 1 over w. And then one more bit of algebra rewrite. The 1 over w, I would write that as w to the negative first. All right, so now I would ask you, hey, what do you want to call the derivative? Do you want to call the derivative y prime? Or do you want to call the derivative dy dw? It wouldn't be dy dx. Our independent variable is an x. So you want to call it y prime or dy dw? It doesn't matter. I'll call it y prime. And we get the derivative to be 2w minus w to the negative second, or if you prefer to get rid of that negative exponent, that's what it would look like. Okay, number 58. Let's see, on 58, I think we're supposed to get the derivative, and get an equation of the tangent line at the point A, f of A. And here A is 1. So you know what? Before I do anything, I'm going to find the point of tangency on this curve. So we put the 1 in for x. And let's see, that would give us a 2 over 3 minus 1. So 2 over 2 is 1. So that's the point of tangency. So to get the equation of the tangent line, we just need to come up with the slope of the tangent line. And we know the slope of the tangent line is given by the derivative. So we need to get the derivative here. For this one, I'm just going to call the derivative dy dx. Instead of y prime, I'll call it dy dx. So quotient rule, the derivative of the numerator times the denominator minus the numerator times the derivative of the denominator, which is 3, all over the denominator squared. So the slope of the tangent line, well, we have to put the 1 in for the x's. So that gives us a 4 times, 3 minus 1 minus 2 times 1 times 3 all over 3 minus 1 quantity squared. 3 minus 1 is 2. 4 times 2 is 8. So 8 minus 6. So we get 2 over 4. It's 1/2. You probably had 1/2. Maybe you used your calculator. Maybe I should use the calculator there. In any event, I know the slope of the tangent line is 1/2. I know the point is 1, 1. So let's use point slope. Y minus y1 equals m times x minus x sub 1. Y minus 1 equals 1/2 times x minus 1, which this is fine, but I know a lot of you, you like to distribute the 1/2 and then add the 1 to both sides to get it in, to get the equation of the tangent line into slope-intercept form. And that's fine. All right, folks, hopefully you got those 3. That's it for this section. It's kind of a short, sweet section, just 2 rules, product rule and the quotient rule. So now you can go do the exercises. So do all these exercises in section 3, 4. Thanks for watching.